Group Brahma classes for JEE and NEET. We are in the chapter thermodynamics. In today's session, we are going to learn about types of enthalpies of a reaction. There are different types of enthalpies. We already studied that what is meant by enthalpy. So enthalpy, right? Enthalpy represented by capital H. So it is total heat content present in a system at constant pressure and constant temperature. Total heat content. Total heat content present in a system at constant pressure and constant temperature. And that's called as what? Enthalpy. Right? We are speaking about types of enthalpies means during a reaction, there will be change in the heat energy of the system. Right? For example, let us take a reaction. Reaction. A gives rise to B, for example. Whatever is the reaction. General format. A is the reactant and B is the product. Right? A is having, let us take 5 joules of energy and B is having 7 joules of energy. Okay. See, now when reactant A is converted into product B, there is some change in the heat energy or heat content. A is having 5 joules, whereas B is having 7 joules, but there is some change, right? Another way what you can write, A on absorbing 2 joules of energy converts into B. Now A is having 5 joules, A has absorbed some energy 2 joules and converted into B, and B is having 7 joules of energy. Right? Now, when you see in the reaction, when reactants are converted into products, there is some change in the heat content. That change in the heat content is called as enthalpy for this reaction. Change in the heat content, or change in the heat, or change in the enthalpy. Right? What is that? There is some change in the enthalpy. Change in heat, or it is also called as change in enthalpy. Change in enthalpy is represented by delta H. If it is represented for a reaction, we write R here. Delta R H. What is R representing? An reaction. It is represented for a reaction. Then this is equal to, right, HP minus HR. Enthalpy of the products minus enthalpy of the reactants. Now for this reaction, what the reaction we have studied, and enthalpy of the reaction is equal to, enthalpy of products is, B is having 7 joules of energy, whereas reactant is having, A is having 5 joules of energy. Total it is 2 joules of energy. That means reactant A absorbed some energy and converted into B. B is having more energy. And we have studied that during a reaction, if some amount of heat energy or some amount of energy, net energy, if it is absorbed, then that is called as a endothermic reaction. What is this reaction called as? Endothermic. So for endothermic reaction, what do we write? What do we write? We write, this is endothermic reaction. This is one way of representing endothermic reaction. Another way of representing endothermic reaction is A gives rise to B. If this energy, if this 2 joules of energy comes that side, then it becomes minus 2 joules. This is another way of representing endothermic reaction. Next, in another way, how we can represent A gives rise to B, we can write it in the terms of delta RH is equal to, okay, so 2 joules. Already we have seen 2 joules. So enthalpy is always calculated per mole. It is always calculated per mole, right? So enthalpy always calculated per mole. So this is one way of representing endothermic reaction. Let us see exothermic reaction. Exothermic reaction. The same A gives rise to B something. A is having some 8 joules of energy. B is having 5 joules of energy. A having 8 joules of energy, when it's converted into B, it has lost how much energy? A gives rise to, I can write B plus 3 joules of energy. 8 joules, 5 joules, 5 plus 3, 8 here. Are you getting this? So this is one way of writing exothermic reaction. Now you see delta H or enthalpy of the reaction is equal to HP minus HR. That is equal to product is having 5 joules minus reactant is having 8 joules, that is equal to minus 3 joules. So when you represent an exothermic reaction, if delta H is minus, then it is exothermic reaction. So delta H positive, endothermic reaction, delta H negative, exothermic reaction. Okay. So what is the other way of representing exothermic reaction? A minus 3 joules gives rise to B. This is another way of representing an exothermic reaction. Here, for this, take an example. Other way of representing an exothermic reaction is A gives rise to B, delta H is equal to minus 3 joules. If you add energy on the right side, exothermic reaction. If you subtract energy on the left side, reactant side, then that is also exothermic reaction. If you represent it in the form of delta H, and if it is minus, then that is also exothermic reaction. So overall, we have studied that during a reaction, when a reaction happens, there will be some change in the heat energy, or there will be some change in the heat content. And we say that change in the heat or change in the enthalpy is called as a enthalpy of a reaction. So what we have to understand? Change in the heat or enthalpy, change in the enthalpy in a reaction or during a reaction is called as enthalpy of a reaction. That change is called as enthalpy of a reaction. Enthalpy of a reaction means during a reaction there will be some change in the heat, and that change in the enthalpy or heat is called as enthalpy of a reaction. So these enthalpies are of different types. When will you call this enthalpy of a reaction as some like enthalpy of formation or enthalpy of combustion? See, for every enthalpy, a specific definition is provided. It is being defined. If this enthalpy of reaction satisfies that definition, then that can be called as either enthalpy of combustion or enthalpy of formation or enthalpy of solution or enthalpy of dilution. So in this way, there are different types of enthalpies. So we are speaking about the types of enthalpies. In that types of enthalpies of a reaction, today we are speaking about enthalpy of formation. What is that? Enthalpy of formation. Let us see. What is this? Enthalpy of formation. Standard enthalpy of formation. Already the name formation represents that something is formed. Something is formed. Here it is mentioned standard enthalpy of formation. So this enthalpy of formation means during a reaction, compounds are formed. When compounds are formed, or where some substance is formed, there can be net release of energy or net absorption of energy. Now only we have said during exothermic reaction there will be some net release of energy. During endothermic reaction there will be net absorption of energy. So when a compound is formed, energy can be either released or absorbed. Energy can be released or absorbed. So here enthalpy of formation is, let us see here, it may be positive. It may be positive or negative. Positive means energy, net energy is absorbed. Energy is absorbed. Negative means energy is released. So both can be possible during the formation of a substance. So first of all, first point we need to remember during studying about this enthalpy of formation is it can be either positive or it can be either negative. And here speaking about standard enthalpy of formation. See definition, let us see the standard enthalpy change. Enthalpy change. Already we have discussed that during a reaction there will be some change in the enthalpy, and that change in the enthalpy is called as enthalpy of that reaction. Here we are speaking about, this is also enthalpy of reaction, but subdivided. Enthalpy of reaction, here we are discussing it in the form of enthalpy of formation. So the standard enthalpy change for the formation of 1 mole. So this is important. 1 mole of compound is formed from its elements. Always from its elements. In their most stable state of aggregation is also known as reference state. And that is called as standard molar enthalpy of formation. What is that? Standard molar enthalpy of formation. How is it represented? Delta F H. This is how we represent standard molar enthalpy of formation. If you write here in this way, or it can also be written as in this way, doesn't matter. Either the way you can write. So this not in the superscript represents that it is standard. If not is not written, it is simple enthalpy. So what does this standard represents? Standard represents that when a compound is formed from its elements which are in their standard states, which are present in their standard states. So let us go with an example here. If you see, let us see. See, hydrogen plus oxygen. Hydrogen, what is the standard state of hydrogen? Gaseous state. What is the standard state of oxygen? Gaseous state. So here only 1 mole, nothing here. Here if nothing is present, what we write? 1 mole. 1 mole of H2O is formed from the elements. What elements? Hydrogen and oxygen present in their standard state, most stable state. What do we say? Standard state means most stable state. Okay. Again, now as this equation satisfies the definition, we can say this enthalpy of reaction, this enthalpy of, actually this is a reaction, this is the enthalpy of reaction. This enthalpy of reaction is called as enthalpy of formation. Why we are calling it as enthalpy of formation? Because this equation is satisfying, this representation is satisfying the definition of enthalpy of formation. So this enthalpy of reaction is called as enthalpy of formation. Enthalpy of reaction, actually this is a reaction. For this reaction, some amount of heat energy is released, and this is called as enthalpy of reaction. And this enthalpy of reaction, I am calling it as enthalpy of formation. Why? Because it is satisfying the condition, definition. In the same way, here carbon in the form of graphite and in the solid state. Graphite form of carbon, allotropic form of carbon, graphite form of carbon is standard state, most stable state. And hydrogen, most stable state is gaseous state. So these two are elements, they are reacting and forming 1 mole of the compound. 1 mole of the compound. So this is a reaction. During this reaction, there is some heat amount, there is some amount of heat released. How much? Minus 74.8 kilojoule per mole. I can consider this as enthalpy of reaction. But this enthalpy of reaction is also called as enthalpy of formation because this reaction is satisfying the definition of enthalpy of formation. Are you getting this? So enthalpy, standard enthalpy of formation means it is the change in enthalpy when 1 mole of a compound is formed from its elements. Compound must be formed from its elements, not from the compound again. Formed from its elements, and those elements are in their most stable state. Most stable state. Then that is called as standard enthalpy of formation. So next example is also satisfying, that is what is formed? Ethyl alcohol is formed. 1 mole of ethyl alcohol is formed. From where? From carbon, graphite is most stable state, and from hydrogen in the gaseous state is most stable state, and oxygen, gaseous state is most stable state. This oxygen, hydrogen, carbon are present in their elemental form, and these elements are present in their most stable state. So it is satisfying the definition of standard enthalpy of formation. So this standard enthalpy of reaction, actually the standard enthalpy of reaction is called as standard enthalpy of formation. See, all these three equations, 1, 2, 3, these three are satisfying the definition of enthalpy, standard enthalpy of formation. So enthalpy of reactions can be considered as standard enthalpy of formation. Let us see the next equation. Here 1 mole of CaCO3 is formed, but is it formed from elements? No, it is formed from carbon dioxide and calcium oxide. What are these? These two are compounds. These two are compounds. From the definition, what we have studied, 1 mole of the compound must be formed from its elements, and those elements must be present in most stable state. Here 1 mole of compound, calcium carbonate is formed, but they are formed from calcium oxide compound and carbon dioxide compound. Yes, this is the reaction. During this reaction, there will be some heat energy involved. There is change in the enthalpy. This change in the enthalpy called as standard enthalpy of a reaction. Can this standard enthalpy of reaction called as standard enthalpy of formation now? Can I call this standard enthalpy of reaction as standard enthalpy of formation? No, I cannot call it. Why? Because this reaction is not satisfying the definition of standard enthalpy of formation. Okay. So next equation, let us go with H2 plus Br2. Yes, hydrogen most stable state is gaseous state, bromine most stable state is liquid state, and HBr most stable state is gaseous state. Okay, everything is fine. But what about this? 2 moles of HBr are formed. We have studied that in the definition, from the definition of standard enthalpy of formation, we have studied that only 1 mole of the compound must be formed. But here, how many moles of compound is formed? 2 moles of the compound is formed. Again, it is not satisfying the definition. So, we cannot call this standard enthalpy of reaction as standard enthalpy of formation. We cannot call, because 2 moles are formed. 2 moles are formed. If you see here again hydrogen is present in most stable state, elemental form. Bromine is present in most stable state, liquid form, and only 1 mole of the compound is formed. Now, the standard enthalpy of reaction can be called as standard enthalpy of formation. I can call the standard enthalpy of reaction as standard enthalpy of formation. Now, from this above equation, if I say enthalpy of reaction is equal to, I can say that 2 into standard enthalpy of formation, because 2 moles are formed. Now, standard enthalpy of formation will be equal to what? Half of standard enthalpy of reaction of this, for this reaction. Which reaction? Let us take it as fifth reaction. For fifth reaction, standard enthalpy of reaction minus 72.8 kilojoule per mole is equal to 2 into standard enthalpy of formation. Because 2 moles of the product is formed, 2 moles of the compound is formed. Okay, so that is about your standard enthalpy of formation, right? So standard enthalpy of formation, how is it defined? It is standard enthalpy change for the formation of 1 mole of the compound from its elements, and those elements must be present in most stable states of aggregation. And these most stable states are also called as reference states. Okay. And that is called as standard molar enthalpy of formation. The standard molar enthalpy of formation of compound is represented as delta F H naught. The reference state, standard state of an element is its most stable state of aggregation at how much? 25 degrees centigrade, which is also equal to 298 Kelvin and 1 bar pressure. 1 bar pressure. The conditions. Here reference states or most stable states, let us take, and most stable states for hydrogen, hydrogen gas, oxygen gas, nitrogen gas, chlorine gas, and inert gases. All these present in the gaseous state are called as reference states or standard states. Reference states or standard states, right? And coming to liquids, bromine, mercury. Bromine in liquid form is the standard state. Mercury in liquid form is the standard state. Solids, all metals, and even iodine. Iodine in the solid state is standard state or reference state. And when element is exhibiting allotropy, the enthalpy is fixed as 0 for whom? Most stable state, most abundant allotrope of the element. Here, it is for elements, in their most stable states or reference states, which is called as a most stable state. This is applicable for only elements. Their standard enthalpy of formation is taken as 0. For example, hydrogen gas, standard enthalpy of formation is equal to 0. Chlorine gas, standard enthalpy of formation is equal to 0. Bromine liquid, standard enthalpy of formation is equal to 0. Like iodine solid, standard enthalpy of formation is equal to 0. When you take allotropic forms, some of the allotropic forms like rhombic sulfur rhombic, standard enthalpy of formation is taken as 0. Because sulfur can exist in rhombic sulfur, monoclinic sulfur. Different types of allotropic forms are present. In the same way, carbon. For carbon, graphite is found to be most stable state or reference state. For that, enthalpy of formation is considered to be 0. In the same way, white phosphorus is most stable state, that is taken as a 0. Understood? So for elements, this is applicable for elements, only elements. Their reference states are most stable states. For that, standard enthalpy of formation is considered to be 0. Elements. Here, for some compounds and elements, standard enthalpy of formation is given in kilojoule per mole. Always we have studied that enthalpies are calculated per mole of the substance. This is carbon dioxide. This is not element, compound. So it is minus 393.5. It is carbon monoxide. And again it is compound. It is not element. How much? Minus 110.5. Diamond is not the most stable one. Graphite is most stable one. So it is 0. But diamond it is plus 1.89 kilojoule per mole. H plus in aqueous form, it is the most stable. So 0. In that way, for elements, especially the most stable state, standard enthalpy of formation is considered or taken as 0. Exact calculation of enthalpy is not possible. Enthalpy is not possible. Only enthalpy change can be calculated. Okay. And in calculating this enthalpy change, the enthalpy of formation of elements in their most stable state is considered to be 0. Taking that most stable state as 0, then the enthalpy formation of other elements of other allotropic forms or compounds are being calculated. Here this formula is very, very important. Based on this formula, we are asked questions in JEE mains and whatever the competitive examinations we are attending. See, enthalpy of formation of reactants is equal to sum of the enthalpy of formation of products minus sum of the enthalpy of formation of reactants. For example, let me take A plus B gives rise to C plus D. Then applying this formula, if enthalpy of formations of A, B, C, D are given, then standard enthalpy of reaction is equal to standard enthalpy of formation of C plus standard enthalpy of formation of D. Okay, these two are products. So products, sum of the enthalpy of formation of products minus sum of the enthalpy of formation of reactants. Sum of the enthalpy of formation of reactants. If there in this equation or reaction we are finding only 1 mole of A reacting with 1 mole of B, 1 mole of C and 1 mole of B. But if you are given 2A gives rise to 3B, then if enthalpy of formation of A and B are given, then for this reaction standard enthalpy of formation of standard enthalpy of reaction for this reaction can be calculated as 3 into enthalpy of formation of B product minus 2 into standard enthalpy of formation of reactant. Okay, so here what we have done, we have multiplied with the number of moles because enthalpy is calculated for 1 mole. So when the number of moles are given, we are multiplying with that number of moles so that the total enthalpy of formation we get. This is for 1 mole, 3 moles are there, 3 into 1 mole. This is for 1 mole, 2 moles are there, 2 into 1 mole. So in that way, if there are number of moles, that means based on the stoichiometric coefficients present in the given balanced equation, we need to multiply with those coefficients. Okay, so that is the concept regarding enthalpy of standard enthalpy of formation. Hope so you understood. In the next video we shall discuss PYQ on the standard enthalpy of formation. Okay, thank you very much.